They told us the future would arrive in a single technological leap. But what if that leap is 1,000 small steps, invisible upgrades stacked inside factories, city grids, satellites, and data centers? Until one morning the world wakes up to a different balance of power? This is the story of how one nation, armed with artificial intelligence, quantum computing, and machines that never sleep, could tilt the scales of global power. This is not a prophecy. It's a thought experiment. But if you listen closely, you'll hear the pattern of a world quietly being remapped. For decades, empires rose on ships and oil, on iron and industry. In the 21st century, the true currency of power is data, computation, and control of the physical world through autonomous systems. Tonight we follow a plausible chain of events, strategic moves, technological breakthroughs, and the policies that connect them. To imagine how a single nation might use these tools to build lasting global influence. We'll explain the tech simply, visualize the scenarios, and imagine the consequences. No jargon, just the facts as they could unfold. Every grand strategy must begin with an engine. For our scenario, that engine is a deliberate alignment of civilian innovation with national strategic goals. Universities designing advanced chips, startups building industrial robots that double as reconnaissance platforms, cloud providers optimizing software with one eye on commercial clients and another on national priorities. What matters most is not a single lab or a single company. It's an ecosystem. An ecosystem where talent flows between tech firms and national labs, where subsidies and procurement quietly steer private R&D toward dual-use outcomes, where data sharing across sectors gives state actors unprecedented visibility into commerce, transport, and human movement. Imagine incentives. Tax breaks for companies that open research centers in strategic regions, fast-track approvals for projects that promise national resilience, and partnerships that give defense planners direct access to new AI models and datasets. Over time, this civil-military fusion creates an invisible pipeline. Civilian tech matures faster because it solves real commercial problems, while the military gets cutting-edge systems mainly as an offshoot of the market. Artificial intelligence is the muscle of this new power, not a single tool, but a layered stack of capabilities. First, perception. Cameras, sensors, satellites, and IoT devices feed raw reality into models that can interpret faces, vehicles, and behavior in real time. Second, prediction. Vast datasets allow AI to forecast supply chains, political unrest, and financial flows days or weeks in advance. Third, decision automation. Software that can recommend, and in many cases execute, responses faster than humans can react. Combine those three, and you have scale. Commercial AI powers factories that reconfigure themselves for demand. Logistics, AI reroutes cargo and controls ports. Surveillance, AI maps movement through cities and across borders. When these systems are shared, through partnerships or mandate, the state gains operational awareness at continental scale. Picture this. A merchant shipping route shows unusual delays. An AI flags a pattern, dozens of small payment anomalies across ports that, when combined, suggest coordinated theft. Within minutes, logistic chains reroute. Within hours, the system isolates the affected nodes. No single human made that decision. The system acted. That kind of speed and integration, when steered by national policy, becomes a strategic advantage. But AI's real leverage is in the margins. Algorithms that subtly favor certain suppliers or prioritize infrastructure investments in friendly states. Over years, these small shifts concentrate economic influence without tanks or tariffs. If AI is the muscle, quantum computing is the acceleration. Quantum machines don't just calculate faster. They solve certain problems in fundamentally different ways. Problems like optimizing enormous networks, simulating complex materials, or cracking cryptography that protects modern communication. In plain terms, classical computers explore possibilities one at a time. Quantum computers can explore many possibilities at once. For some problems, like finding the optimal route through millions of ports, or modeling the interactions of thousands of financial instruments, quantum approaches can deliver answers orders of magnitude faster. Now imagine a nation that achieves practical quantum advantage in a few key domains: logistics optimization, materials discovery, and code breaking for legacy encryption systems. With quantum-accelerated logistics, state-backed enterprises could move goods and components with uncanny efficiency, undercutting competitors and dominating global supply chains. With quantum-enhanced materials research, they could field new semiconductors or energy storage devices years ahead of rivals. And then there's the darker capability: cryptography. Much of our secure communication still relies on mathematical problems that quantum algorithms could break. A breakthrough here doesn't instantly overthrow the world, but it gives the possessor the ability to read decades of recorded communications, to decrypt old secrets, to harvest intelligence that reshapes diplomacy and strategy. Combined with AI, quantum computers become the turbocharger. Quantum speeds up certain model training, accelerates simulations that inform AI decisions, and unlocks a class of predictive power previously inaccessible. The third axis is the physical: robots. Small drones for surveillance, medium drones for logistics, and large industrial robots that build things faster and cheaper. A factory floor populated by millions of coordinated machines can produce goods at a scale and pace a human workforce cannot match. Autonomous ships and long-range drones extend presence across oceans without risking sailors or pilots. Consider this scenario: hundreds of thousands of low-cost drones, both airborne and ground-based, serving dual commercial and strategic roles. During peacetime, they're delivery tools, crop monitors, and infrastructure inspectors. During a crisis, their flight paths and behavior can be repurposed for reconnaissance, interference, or kinetic missions. Because they are mass-produced, their loss is less costly. Because they're intelligent, they coordinate in swarms that can overwhelm defenses. Robotics also reshapes labor markets. As manufacturing becomes automated, the comparative advantage of nations that master the robotic stack grows. Exports shift from cheap labor to high-throughput, low-cost manufactured goods, giving strategic control over critical supply chains like batteries, semiconductors, and medical equipment. Now we stitch these threads together into plausible scenarios. Not inevitable outcomes, but credible sequences that show how influence could expand. Scenario A: economic encirclement. Over a decade, state-backed firms captured dominant shares of key supply chains: rare earth processing, chip packaging, battery assembly. AI-driven logistics make their exports cheaper and faster. Countries that rely on these supplies become economically entangled by contracts, software dependencies, and data-sharing agreements. When disputes arise, the supplier can subtly throttle capacity, raise prices, or demand political concessions, not by force, but by leverage built into commerce. Scenario B: intelligence. Surplus. Massive datasets collected through commercial platforms are analyzed with quantum-aided AI. Patterns emerge: the true loyalties of political factions, the financial vulnerabilities of influential corporations, or the clandestine relationships between nations. With this visibility, diplomatic strategies become surgical. Coercion becomes targeted, silent, and effective. Sanctions and incentives are delivered precisely where they will change behavior. Scenario C: gray zone. Control. Robotic systems and AI are used to create persistent presence in contested spaces without formal military deployment. Swarms of drones patrol maritime routes, monitor resource extraction zones, and project power under the guise of commercial operations. Satellites and ground sensors feed algorithms that can disable or distract opposing assets in critical moments, jamming communications, corrupting logistics data, or overwhelming monitoring systems with false signals. The result: control without declaration of war. Scenario D, cyber-physical edge. Quantum-enabled code breaking is used selectively to recover decades of encrypted communications. Historical intelligence reshapes current negotiations. Simultaneously, AI-guided cyber operations target supply chain software, subtly inserting delays or errors in competitor manufacturing. The cumulative effect is a world where one actor can steer market outcomes, diplomatic balances, and military escalations from a distance. How might a global superpower like the United States respond? In our scenario, the U.S. retains enormous strengths: deep capital markets, advanced research institutions, and global alliances. But the rise of integrated AI quantum robotics systems complicates conventional strategies. First, strategic surprise. The speed and subtlety of automated systems compress decision cycles. Democracies, with their deliberative processes, may struggle to match the rapid, opaque moves of automated networks. Second, economic exposure. If critical manufacturing and logistics are deeply outsourced, geopolitical tension can quickly translate into shortages. Third, the information battlefield. When adversaries can forecast political trends and subtly manipulate narratives through tailored automation, democracies face new vulnerabilities. The response can take many forms: strengthening alliances and diversifying supply chains, investing heavily in domestic AI and quantum capabilities, imposing export controls and investment screenings, and building resilient decentralized infrastructure that resists single points of failure. The outcome is not a zero-sum collapse, but a prolonged contest of adaptation, where governance, law, and public norms must evolve to manage the sheer speed of technological change. Technology alone doesn't win hearts and minds. The real power lies where technology meets human systems. Surveillance and automation can undermine privacy and agency, fueling distrust. Economic disruption can create political backlash and instability. And when states weaponize civilian platforms, the line between commerce and coercion blurs. There are important ethical questions. Who decides when an autonomous system takes action? How are errors corrected when decisions are made at machine speeds? What checks exist on quantum-enabled intelligence gathering? Democracies must craft robust legal frameworks, transparency standards, and international norms to prevent abuse, while still competing technologically. If a concentrated technological edge can reshape global dynamics, so can coordinated defenses. 3 broad responses reduce risk. 1. Resilience. Diversify supply chains, build redundant systems, and decentralize critical infrastructure to avoid single points of failure. 2. Regulation and norms. Global agreements on AI use in sensitive domains, on quantum cryptography standards, and on limits for autonomous weaponization can reduce escalation risks. 3. Investment in people and open science. Democracies can close gaps by funding research, training talent, and maintaining open collaborations that balance security with innovation. Most importantly, transparency matters. If advanced capabilities are hidden and trusted only within closed circles, miscalculation becomes more likely. Open standards, independent verification, and international institutions can create guardrails that make competition safer. So what did we learn? That control is rarely a single dramatic seizure. It's often 1,000 quiet steps: policy decisions, subsidies, partnerships, algorithms tuned to favor certain flows, factories optimized to produce at scale, and machines that extend presence without human crews. The combination of AI, quantum computing, and robotics can amplify power in subtle and dramatic ways. This thought experiment is not a call to fear, but a call to prepare. Technology will change who holds power, but governance, law, and collaboration will shape whether that change makes the world safer or more perilous. The choice is ours: to build resilient systems, to write rules for new machines, and to keep the future a product of many hands rather than the exclusive domain of any single state. Thank you for listening. If this story sparked questions, imagine the next chapter: how alliances, startups, and citizens might respond. The future is not written. It is being computed piece by piece.